Hey everybody, just wanted to show you a little update I did to my do-it-yourself rig. It's really simple. I re-drilled my hole here. I used to have one kind of in the center. Now I've got two separate holes, so I've added weight back here and a little up top too. And the idea is I want to make it easier to get it heavy on this end, because this mount has a fair amount of backlash, especially in declination. And if I can get it to where this end's heavier, it'll help reduce it, especially if I've got it pointed straight up. Because if you're pointed straight up and you're heavy on the nose end up top, then it's kind of like having a building that's top heavy, and it doesn't work very good. So you want it to be heavier down at the base. So like I said, I've added about 4 pounds of these fender washers, and I'm going to test it out tonight, see how it improves my guiding. I think it's going to make a nice difference. It wasn't bad before, but I noticed if I put my 6-inch Newtonian on there, it guided more stable. That thing's heavier. So now with this whole setup right here, the weights, the guide scope, and the camera weighs about a little over 17 pounds. And before, I guess it was about 13 or so. So now, I'm not sure if the weights are showing up here on the camera, but I've got 2 counterweights on here now instead of just one. So I've got a 12-pound weight, which came with the mount, and an 11-pound weight in addition. So I think that's going to help a lot. So tonight I'm going to be using the Nikon D50, and this is a 300 millimeter lens. It's not one of the zoom lenses. It's 300 millimeter only, f4.5, and this is an old lens. I got this for like $60 or so, but it's close to 50 years old. So it's manual focus, and I just set it on infinity. The neighbor's going by, and so that way I like that because I can it's easier for me to focus. Now some people, depending on what camera you use, you might not be able to just set it on infinity and go, because there's a set screw in here somewhere where they can adjust where infinity is on the lens. And I think since I've got an old camera with large pixels, it helps. I get away with it. Okay, so I'm going to show you how I go about setting up my Celestron AVX mount with my computer, so that I'm going to control it with the computer instead of using the hand control and its buttons. So what it does is it bypasses this, but I still need it. So this particular one, it's got a USB cable down here, and it becomes a serial port is what it does. But I'll show you how I go about hooking that up so that normally I get connection consistently. Because when I first started using this, it all depended on what I turned on first and what I connected first. Sometimes it worked, sometimes I had to fight it, and I discovered a little trick. And what I do is, before I connect my AC cord up here to the mount for AC power or DC power if you're using a battery, I connect the USB cable from the hand controller to my computer, and that sends just enough power to illuminate the hand control. It won't send any power to the mount. It won't actually move or anything, but it'll have the word initialize show up on here. And after I get that on, then I connect my power cable and plug it into the wall, and then power on the mount and connect to CPWI. Now, one of the things I learned that was very important about using this mount with CPWI software is I have to plug this USB cable to the exact same USB port every time. And the reason is because the computer thinks this is a serial port, which serial port is something that existed before USB, so they had to figure out a way to adapt it because they kept using the same technology. So when I initially installed the hardware, the very first time I plugged the mount in, I did it on the left-hand USB port. So I need to keep doing that on that same port. If I do it on a different port, the computer won't be able to find it. And if that happens, that means I have to control it with the hand controller instead of the computer. So now we'll go around and we should be able to see that the hand controller has illuminated. Okay, I don't know how well you can see it on the screen, but the word initialize is here. So I can see that. And if it was dark outside, these keys would all be orange. They would be illuminated. So now that that's set up, I can go get my power cable and connect it up here and power on the mount, and then I'll power on CPWI software. And the mount will get the date and time and all the location information, my latitude and longitude, from my computer. If you don't use your computer, it's all in your hand controller. Now I'm using the same power cord that came with this mount from Celestron. It's got a, I don't know if the older mounts were like this, but the newer Celestron AVX mounts, you slide it in and then you can tighten up this little knurled collar. And I've learned from Facebook groups that I'm in, some people tighten this too tight. And what you need to realize is this thing's just connected to a little circuit board, because all it is just a little computer board. And there's just two little pins, or maybe three, and they're soldered in there. And if you tighten this too tight, eventually you'll break that solder connection, and then your power connector won't be good anymore. So here's my AC adapter. I bought a generic one. It's I just bought it on eBay. It wasn't very expensive, and it's one that plugs into, it has a cigarette lighter plug on the end of it. So this here's the piece that came from Celestron. And I got in the habit, initially I was just storing it inside this Ziploc bag to keep dew off of it. And then a winter or so ago, when I had this sitting outside, I had this piece here, the AC brick, setting directly on the concrete, and it got cold out, and I think I had a drop in voltage, because after an hour or so the mount just stopped. I couldn't slew it, couldn't track it, couldn't do nothing. Brought it back in the house, let it warm up for a while, and it worked fine. So since then I put it inside this cooler, and I've just got a couple towels in there. Close the lid, just generates a little heat, and I've used it on pretty cold winter nights and it works fine. So now obviously just plug this in. I've got one electrical cord for my mount and the other one goes to my computer, because I'm using a desktop type computer. So I don't really run anything off battery. And that's just a ground fault circuit, GFCI type of outdoor plug. My controller still says initialize, so I can just go ahead and power on the mount. Now I discovered I like using a wireless keyboard, because this way I can carry the keyboard around to the mount. If I want to look through something and fine-tune my position, I can use my arrow keys. And what I've got here, I've just got some white tape, and this is so that when it's dark and I grab it, I don't accidentally start pushing buttons. Because one night before I did this, I don't know which button I pushed, but I guess I put the computer to sleep. I use this little two-wheeler cart for my counterweights. That way I can just wheel them back and forth instead of carrying them. Comes in handy if you have 2 or 3 of them especially. Okay, so now let's get CPWI going here. And for the AVX, you go up to connection. You don't go to this mount USB. There's different Celestron mounts can use that. The AVX, you want hand controller.
Now, if you have some kind of a Wi-Fi module, maybe you can do that. I've never tried that. I don't have one. Okay. Now, part of this may not show up here at the very bottom, but it's got me hooked up. It's got my location. It's got today's date, night before Halloween. And I'm going to go up here to manual align. And I know it's below my thing, but I'm going to click the ready button after it tells me to move it. So what happens here is I got to use my arrows, which I can do with my keyboard, or I can do it on here, either one. But if I do it with the keyboard, I can carry the keyboard right up to the telescope. And I'm going to get my RA and deck marks lined up with the index marks. So I'll show you that.
So of course I've got my RA, index marks, and declination marks. And the way I do it, I have it set to where I finish the move with up and declination and to the right in right ascension. And it does that way automatically too if you tell the mount to go somewhere. I'm moving to the east, and then I'll correct it going back to the west. And I can slow it down. I can push D and then choose a number between 1 and 9. 9 was fastest. I'm going to slow it down to 7. And we'll do the same with the deck. Okay, so now I've got my index marks lined up pretty well.
So now that I've got my index marks lined up on the mount, I'll go ahead and click ready. And it's going to ask me to choose a star to help align. Now, depending on your setup with what you got, you don't necessarily have to use this. I like to use it and at least get a star set up. Since I've got my DSLR on there, I can do plate solving, which I think that's another video in itself, which I need to do that, but that'll tell you where you're at anyway. But since I'm on here, I will go ahead and pick something that is supposed to be up in the sky, and we'll just pick Deneb. It's daylight still, so I'm not going to see anything, but I'll show you how this works. So I'll go to Deneb, and you might be able to hear my mount moving. So the computer thinks it has the telescope pointed directly at Deneb, and then what you're supposed to do is center it in your eyepiece. And if I'm using an eyepiece, I like to start with a low power eyepiece. Makes it easier to find it, and then I'll put in a higher power one, preferably with a illuminated crosshair, and get it right dead center, and then click centered, and we'll just say that it's centered. And then as you can see up here, we've got Deneb, and then we can go find another one. And this is, as far as the Celestron idea, this gives it a pointing model, because down here it'll tell you what your error is in polar alignment, and right now it says unknown because it's only went to one star. I'll tell it to go to Vega. Okay, so now it says it's on Vega. Like I say, since it's daytime, I'm just going to tell it it's centered. And even though I didn't make any adjustment, for some reason, it thinks there's some kind of an error in my polar alignment. And I'm not going to let that worry me too much. But it's saying it's pretty close to dead on. And so then you can do as many stars as you want, and you can fine tune it too. I found that helps. Like if I was let's say I was trying to find something over here in the vicinity of Cassiopeia here in the old crown. This star shatter is really bright. Matter of fact, all of these here are reasonably bright, and I found if I center each and every one of these dead on, either in camera or in an eyepiece crosshair, it's really accurate to go around here and find something that's kind of faint and fuzzy. So that I found that helps. So I'll just go ahead and tell it to go to shutter, just so I'm doing something. We'll have 3 stars. We'll just put a few of them in here. And you can see the position of the mount changing as it's going towards where it's going to go. And then it's kind of fine-tuning there at the last second, coming again from below and from the left. And I'll just say that's centered. So it has the coordinates for each star. And like I say, any error, which, like I say right now, it's saying there's almost no error, but I lied to it and told it it was perfect. So then I can hit finish and alignment complete. And if I actually had an error in these to any amount, it would offer all-star polar alignment. And what that does is it asks you if you want to do an ASPA type alignment, and it'll tell you to center the star that you choose in the eyepiece, and after you tell it it's centered, it'll adjust the position and say this is where it should be if the mount was polar aligned correctly. And then you move the adjustment screws on the mount itself, the altitude and azimuth ones, adjust it east, west, north, south, and try to center it. And if your polar alignment was off a lot, that might actually throw it out of the field of view of the eyepiece. That's why I have 3 black dots painted on my concrete driveway. So I just come out and set the tripod legs on those, and I'm really close every time. I could be typically less than 1 degree error. So I'll go ahead and hit exit. And let's see, in case you're not familiar with the software, since I did that, the slew control went away. So if I go over to mount, you can tell it to stop or whatever. I hit slew controls and it brings that back up, and I can change my speed, of course. And then you can hit configure, and this brings up a menu. You can change how fast the fastest speed is. I just left it at normal. Backlash, this is an adjustment to help correct backlash when you move from one place to another. They typically advise not to use this with auto guiding. Auto guiding software has its own backlash built in, but this can fight with the auto guider, because if the auto guider doesn't know that this is happening for a specific reason, it'll think, oh no, the star's drifting off, and it can cause problems. So then I set my slew limits here, which I've already got these set, and this is just to keep your telescope from running in a tripod into the tripod leg. And that's a good thing to play with during the daylight, so you can see how far you can get away with going, because it's really different with every telescope, depending on if you have a big long refractor or maybe a little bitty refractor or whatever. And then the auto guider rates with the AVX, I've read that you should try to keep this as high as you can, and I set it to 99, and for some reason it goes back to 96 usually. And we've got our choice between sidereal, lunar, and solar. So for the stars, obviously I want sidereal, and then solar if you're doing the sun, and lunar for the moon. And the reason for that, if you're not familiar with it, is the stars don't move across the sky at the exact same speed as the sun or the moon. I believe the stars and the sun are very close to being the same speed, but there's a slight difference, and the moon is noticeably slower. So if you're watching the moon and you have it on sidereal, you'll notice that it wants to keep drifting. And you can also put it on RA and deck tracking, which I think is supposed to be for if you have altitude azimuth type setup. But I've been thinking on the idea that it should work with the moon too if you're got it tracking all through the night, because the moon's right ascension and declination can change a little bit during the night because the moon doesn't follow the same path through the sky as the stars. I'll go ahead and click accept. Let's see, alignment. I don't mess with most of this. We're here to perform all-star polar alignment. Now, let's go ahead and go through it since we're talking about it. So it tells what the error is, and I'm just going to click next. And it's going to tell me to select one of these stars and then click go to. So I'm going to click one that I was actually on most recently. And it was over there in Cassiopeia. So that's what I normally do when I'm doing this for real. I pick the star that I'm already pointed on. Makes it a little quicker. So I'll pick that and it'll say go to shutter, and it's going to make just a tiny little adjustment. And then it's going to tell me to center it in the eyepiece, and then click centered when you're done. So now it's telling me that it put the star in the place where it should be if my polar alignment was correct. So then I would adjust my polar alignment knobs on my mount to center it up. You do that instead. You don't use your up and down arrows or anything on your, you don't move your motors. So I'll show you that with the camcorder real quick.
So then for all-star polar alignment, to recenter the star, like I say, instead of using the tracking motors, you adjust your east and west, which is your azimuth. So you loosen one and tighten the other, and it just rotates the mount a little bit east and west. And then you have your north and south, one on the back and another back around on the other side on the front. And you do the same with them and make an adjustment north and south. And you just try to make really small adjustments to fine-tune that as close to center in the eyepiece as you can get. And then you tell all-star polar alignment you've done that, and it'll tell you that you're polar aligned correctly. And that should have you quite close, but if you're doing photography, when you get into PHD or whatever guiding software you're using, it's a good idea to use drift alignment, because that's really, your photography is the real answer to see if your stars are round. Because some people say that this is not exact, and from what I've learned, I'd say they're right, but it helps a lot. It gets you pretty decent. I found my eyepiece tray is a nice place to put my AC adapter. For this one here is for my Nikon D50, and then I've got another one here that I use for USB dew heaters. And I've got it held on here. This is just a Velcro strap. It's just, there's no glue to it or anything. It's just Velcro. It's got the stuff on each side. And you can buy it at places like Walmart in the fabric department where people are sewing and stuff. And it's not very expensive. You can get a big roll of it pretty cheap. So right here is my homemade observatory desk. I made this out of 3/4 inch plywood. I bought pre-cut at Menards, and I've just got it bolted together using 90-degree shelf brackets. And then I've got some pretty heavy-duty rollers. They're like, the wheels are probably 3 inches in diameter. So I've got them bolted on the bottom. And I've got a little tower type computer under there. And I've been using this thing for 10 or 15 years. And it's worked really well for me.
One of the things I like to do after I connect with CPWI, I like to control the telescope with PHD2 Ciel. It's similar to Stellarium, so it really doesn't matter which one you use, and there's others you can use as well. So I get on here and I'll connect the telescope. So I'm already connected with CPWI here, and it knows where it's at. This here, I just like this because it's just kind of user friendly. It's got a lot of information on it. I'm just accustomed to using it. And I'm also going to click Track Telescope, and that'll align the map with where I'm pointed. I just pointed at an alignment star over here. Now, one of the things I really like about using this PHD2 Ciel software is when I'm setting up, when I go to do my drift alignment with PHD2 software, which is just part of the calibration for guiding, it wants you to go approximately due south and near the equator. So that means I want to be at 0 degrees on declination and 180 degrees on azimuth. So it's this telescope connect menu that I'm using there has that. So I'll work my way back here. You can see here I'm going south. Work this towards 0. And I don't always just go directly to it. I kind of go a little at a time since I've just been setting up, especially if I'm nervous about cables. Now, I did say something about going due south, but you're actually supposed to be within about 15 degrees. And the reason I want to stay on one side of it is because when you cross the meridian, you go from, say, 180 to 180, 182 and all that, eventually it's going to do a meridian flip. Since it's an equatorial mountain, I don't want it to try to flip in the middle of it. So since I have the telescope pointing towards the east part of the sky, I'm going to keep it about 15 degrees east of due south, which will be around 165. So I'll get that close to that, and then I'll still get my deck close to 0. And then I'll hook up my PHD2 to the guide scope. And I went down south and now coming back forward, and I've got it slowed down. The 9 really gets moving quick. Okay. You can see me fumble around a little. So try to get the backlash out of it. There we are. And then I'm going to move back west a little bit. Or east, I mean. And pull the backlash out. Now see, it says where it's at, but it might not be exactly there because there's backlash when you change directions. So this is just where it thinks it is. So now I've got my guide camera connected to the cable, and I'm going to connect my equipment here. But as you can see, in this case, I've already got these selected by default because I always use my Orion Starchart autoguider, and it connects to CPWI through an ASCOM driver. So I'll click Connect All. Okay, and sometimes it disappears on me. And then I'm going to set my exposure time. I'm going to start with 3 seconds is what I usually start. I'm going to click looping and let it start looking for a guide star. So now we've got a pretty bright star. And if by chance this area over here on the left, which in my case it's on the left because that's where I put it, I think you can personalize it. But if that starts flashing white and gray and just changing colors, that means you're out of focus. Because if this is what it's doing is adjusting the sensitivity or the gain, because it's auto gain on this particular camera at least. So if you're way out of focus, it can't find anything, and then once you get your focus close, it'll settle down. Now in this case, it says I found a very bright star, signal to noise ratio over 72. I'm going to shorten my exposure. This mount is known for being happier when it's got a short one, and I'm still at 36. So I'm going to start guiding, and it's going to go through calibration. And you'll notice down here in the bottom left-hand corner, it's making steps to the west, and it's measuring the distance that it moves. So what it's doing is it's measuring how far the star moved across the screen. I think it's counting pixels, where it says distance 19.8, 12.3, stuff like that. So it's done its west moves. Now it's doing east. Now it says it's clearing out the backlash. And then it's going to do the same thing for north and south. And depending on your setup and whether or not you've got issues with backlash, it can take longer. Having my exposure time at a half a second is really helping me out with this too, because if it was at 3 seconds, well, it'd take 6 times as long between each move, because it would make a move, wait for the next exposure, and so on. But there are a lot of people that have better mounts than an AVX that prefer to go with longer exposures, 3 seconds or whatever. Okay, now it put up a little message up here in the top, which some of it may be out of the view of my screen finder, but it's just telling me that my previous time that I calibrated was different than this one, and it's because of backlash and declination typically. So I just ignore it and hit close. That's what I do anyway, not everybody obviously. I'll show you another little thing here. So now that I've got it guiding, I'm going to use a nice little tool here. And the one I'm using is called the Guiding Assistant. And this helps with your calibration. I won't make you suffer through the whole thing. I'll pause it. But it measures for at least 120 seconds or 2 minutes. And it starts telling you how far your polar alignment is off and all that. And it'll make recommendations as well. I'm going to pause the video for a minute. So it's done its 2 minutes part, and it says that my polar alignment error is about 10 arc minutes, which isn't perfect, but depending on who's looking, it's not horrible. I'm going to click stop, and since I did not deselect this measure declination backlash, it's going to try to measure it. And like I'd mentioned, my mount, the Celestron AVX, has a lot of backlash, and we typically try to balance it slightly heavy on one side. Like in this case, especially in deck, I'm trying to make it a little tail heavy at the back end. And then a lot of people say to go east heavy with the east and west. So I'll let it measure, and I'll pause the video. Sometimes it doesn't even find the error. It's so much it doesn't give me a number. So we'll see if it does. So this is one of those times when it said it could not establish how much backlash there was. That's why a lot of times I don't even check this box. But I have had success with it a few times, and it's a very high number, like 8 seconds, 10 or 11 seconds. That's way too high for what it should be, but this is not an expensive mount. This is one of the least expensive mounts you can get for guiding and be able to have any kind of heavy equipment on it. But it's given me some advice here, about my exposure times. It says 1 to 3 seconds, and like I say, because of the backlash, I find it's usually happier if I can get it as short as I can. So half a second's usually nice. Sometimes if I go shorter, then it might really start getting into the seeing and everything and overcorrecting. So I just kind of have to fudge it. And it's telling me that my polar alignment could be better. And then these minimum moves that it's recommending here it's saying that if the error is larger than 0.13 to make a correction, and then in declination if it's larger than 0.2 make a correction. So I hit apply, and it just puts them down here for me, and then I can change those if I want depending on how the mount's behaving. And I'll clear this out, all this junk here where it's going way off because of all the calibration. So I'll hit clear, and it's just going to give me a refreshed image. And hopefully it's a lot happier too, because this is the time that I'm testing my change that I made to that DIY adapter that I made for my DSLR, where I added extra weight to the back of it. Tonight's the first night I've tried it. And so far I'm liking the numbers. It may not stay like this, but right now it's less than 1 arc second, and you can also see it listed over here. Up here, these peaks are the maximum error. This other part's kind of like an average. So you get an average of the RA, an average of your declination, and then a total where it combines them and gives you a number. But like in the case of my camera I'm using right now, which is the Nikon D50 with a 300mm lens, my imaging scale is around 5.4 arc seconds. So since these peaks are well below that, that thing will be really happy. Usually if you can get anything less than 1 arc second with this mount, you're doing really good. So it looks like right now I'd say the change I made is really helping me out a lot. When I start getting big backlash problems, it's usually declinations the most. It'll go way up here, get a big spike off the chart sometimes, and then overcorrect it because of backlash. So what happens is it's trying to spool in that backlash. It's kind of like loose wire, or if you're running your dog and it's got slack and you're trying to pull him tight. So you got to pull in all the slack, and then sometimes it would overcorrect and go way down here. But it's looking really happy. And I noticed it was this way when I had my 6-inch Newtonian. It was happier, and from what I've been reading online on Facebook groups about this specific mount, this mount seems to like it when you have more weight on it. It doesn't necessarily like longer focal lengths. They say 1,000 millimeters is where you start to get in trouble. And I think part of that also depends on your camera, because if you've got a camera with really large pixels, it'll forgive you a little more of that. If you've got a camera with really small pixels, which a lot of the newer cameras do, then that's a big problem. But I'm really liking these numbers, so we'll keep an eye on it and see how it keeps doing. So now I've actually moved to a different star. The one that I was guiding on initially was the same one I calibrated on, and it was getting close to due south, and I didn't want to get into the business of it crossing the meridian and all that. I usually work on one side. I don't do automatic meridian flips. As you can see, when I first started guiding on this star, my declination started to go off, and then it corrected it. So I'm thinking it probably corrected backlash. And since I've got a nice short exposure, it corrects it pretty fast. If I had been doing a 3-second exposure, since this thing has a lot of backlash, it might have went way up high, and it might have taken 3-4 minutes to clear off instead of 20 or 30 seconds. And it's down, looks like just under an arc second. And that number may get slightly lower when this disappears. Once this gets to the far side, it'll start to, this will move off to the edge. So as you can see, now my graph is moving the old stuff off to the left. I've got new stuff coming in here. So my numbers here are going to adjust some to the better when this bad part disappears. So that's one thing when you first start your guiding. If you have some great big spikes, you'll have some bigger numbers over here, and if it settles down, those numbers will calm down too. But you just got to remember, if those happen during your exposure, you know, it's going to be part of it, even though you look at it and say, well, I'm guiding under less than 1 arc second or whatever you happen to be at. So in case you're not familiar with it, I've got my focus helper up here. You want this to be a relatively sharp point. And here is the star as well. Sometimes that when I used that tool to check my backlash and polar alignment error and all that, it'll tell you to improve your focus. As a matter of fact, the last time I used it, it told me to. And I thought, okay, I'll do it. I'd been getting away with not doing it, and I thought, well, I'm going to fine-tune it. And, you know, it had confused me a little because this keeps continually changing. And your numbers down here, you want this to be small. It'll keep changing. You know, I mean, it's jumping from 2 to 4 every now and then. But what I also noticed is my signal to noise ratio. And when I started fine-tuning my focus the last time, I noticed that this started improving. So I started going by the signal to noise ratio to fine-tune it, and the number went up considerably. And also the star here, which is another window I brought up. You can, like I say, you can personalize all this. You just have to play around in your menu to find them. I had to search for a while and look online for instructions. But that, you'll see it improve on there. Now if you look down here on the lower right, you can see the corrective moves it's making. Left and right for east and west, and up and down for north and south. And when you compare that with this, you'll notice that it doesn't necessarily make a correction every time you see this spike up or down. and that's because of your minimum move here. If this move that the stars moved, how many ever fractions of a pixel, is smaller than these numbers, it won't bother making a correction. And then if you have a backlash problem, you'll notice, especially in deck, it'll start making really big corrections. Like right now, I'm getting a little bit of it's dropping down here. You might see it make several moves. And if it's really bad, it might move for several seconds. And when it does that, that's when you're likely to get a big overcorrection. And sometimes it corrects itself pretty quick, and then sometimes if you're really having problems, it'll just keep doing it over and over and kind of drive you nanners. So if you remember, I mentioned the image scale, so that's the scale of the camera that you're imaging with. In this case, I'm using a Nikon D50 and an old vintage Nikon 300mm lens. And it says my image scale is 5.3 arc seconds. And this software, this is a really old software program this guy Ron Wadowski put out there for free years ago. I don't even know if you can still find it, but I've just had it available. But you can get this same information off of websites. There's several websites that have it. I think you can even get it in Carte du Ciel. If you search around where you enter your information, it's probably, I wouldn't be surprised if it's in Stellarium. As you can see here, I've got 5.3 seconds, so that's supposed to be the smallest detail that my imaging camera will pick up. And I want the errors in my guiding to be considerably smaller than that, so that the errors in guiding never show up in my image. So I'll close that. As you can see, at least right now, my average figure, gee, 1.12, that's fantastic. And my peaks here, they're staying well below it. You know, 3 and 3.3 or what have you there is well under the 5.3 of the imaging camera. So as long as I don't get great big spikes, it shouldn't even show up in there at all when this starts dancing around, which can kind of get you nervous sometime. I think what this here is just from the backlash. It took a minute or two to pull itself out, and it may turn around and do it again. And you can fight it all night, or you can say leave well enough alone. It just depends on your equipment, and especially if you're just learning. If you're getting reasonably good pictures, you know, I'd try to avoid spending all night fighting this stuff, because next thing you'll know, whatever you're trying to take a picture of is gone, or you have to go in the house or whatever. So anyway, yeah, I think this change I made to the mount by adding more weight to the back of that do-it-yourself adapter of mine looks like it's a big plus. It looks like it's improved quite a bit, so I'm liking it. Here's a nice example of a backlash overcorrection in PHD2. Now, fortunately, it corrected itself pretty quick, so I can deal with that. Now, this big spike in declination may actually be caused by me walking back and forth. I've got this set up on my concrete driveway, which seems stable enough. There's been a couple of times this evening where I went in the house for a few minutes and I came out, and all across here it just looked pretty nice, and all of a sudden right over here on the right a big spike showed up right as I got here. And I don't know if somehow I'm making a vibration or what, but that's interesting.